Okay, class, this video notes is still on 8.2, but this time we are going to talk about the ambiguous case. Okay, so what does this mean? The ambiguous case, it's so special, right? You're gonna be given a side. Let's call this side leg B. You're gonna give it another side, okay? Let's call this side leg A. And then you're going to be given an angle, this angle A. Okay, so let's talk about this really quickly. So again, all of these triangles are giving side, side, and an angle. Side, side, and an angle. And it's called the ambiguous case because number one, it will sometimes give you no triangle. Number two, it will sometimes give you one, but it's a right triangle. And number three, it's gonna give you two triangles at times. Oh my gosh, how is that possible? So now let's go do a animation of this really quickly, okay? So notice how the reason sometimes you have two triangles is this one. Notice how one can be formed on the outer one and one can be formed on the inner ones, okay? So depending on this side, the first side, let's call it side A, depending how it is positioned, it can give you a different kind of triangle, okay? So let's go back to our case number, oops, I didn't want to do that, but I guess I did. Okay, case number one. What if, okay, so let's call this angle A, which is already here. This leg A, let's call leg A is always the opposite leg of an angle. So let's call it the opposite leg of an angle. And let's call this leg B adjacent leg of the angle, okay, for the sake of argument. So the angle, it's number one, when you draw this out, always put the angle on the left side. Then draw an opposite leg. You're not going to have any triangle at all if the opposite leg, can you see this right here? It's shorter than the height, okay? Because for it to form a triangle, you would need to have a height to connect to the base. Okay, here's your base. But if the opposite leg, it's shorter than the height, it will not form a triangle. So that's the problem number one. So we're going to write case number one, no triangle when your opposite leg, it's shorter than the height, okay? Case number two, when this opposite leg, okay, remember this opposite leg, we don't know how long it is, okay? It can be long, it can be short, as long as you can swing it in and out. Now, this opposite leg is going to be exactly one triangle if opposite leg is the same as the height. Can you see this right here? Okay, so case number one, opposite leg is the same as the height. Also, this opposite leg will also form, oops, I can't erase, why can't I erase? It's frozen, give me a second. There you go. So again, this opposite leg is something that is given to you, okay? It will form one triangle, as stated earlier, if this opposite leg is the same as the height, or this opposite leg, it's shorter than the adjacent leg, okay? Because this opposite leg, keep in mind, this opposite leg can go in, or can go outward, or can go straight down, okay? But it can't be too long, okay? So what if it's too long? Sorry, this opposite leg is equal to the height, forms one triangle. I take that back. This opposite leg has to be exactly the same as the height to form one triangle. Or, it has to be longer than the adjacent leg. Remember we call this the adjacent leg? Because if it's longer, then I can move it out here, okay, and make this triangle out here. Because all we know is this is given, okay? This is given, and given. We do not know how long the base is. The base can be as long as you want. So if the opposite is so long, I can swing only to the right. Okay, that means swinging this way, swinging all the way out here. So if it's so long, I can swing it all the way out here. And I can't swing it over here because then this would change my angle here. So if one triangle again, if the opposite leg is greater than or equal to the adjacent leg. Okay, so if it's so long, you can expand it. Okay, if it's so long, let's remember this base is as far as it wants. It's so long that I can move it all the way to the right side and make an obtuse triangle. So that's another one when you get one triangle. Case number 3, 2 triangles. This is the one that's really difficult to understand. So check this out. Remember, your height is still here. Okay, this is still your height. This A value, again, let's call it the opposite leg. And this B value is still the adjacent leg. And this angle is another given angle. This opposite leg is going to form 2 different kind of triangles. Okay, if as you can see, if it's longer than the height but shorter than the adjacent, because if it's longer than the height, then you can swing the opposite leg, right, outward. Okay, remember this base is unknown. You can swing it outward like that because your height is still here. So that's triangle number 1. This is A is given, adjacent leg, opposite leg. Another one is when you swing it inward. Okay, if it's longer than the height, you can swing it in here, right? And make this triangle because your height is still right here. But it's not so long. It's not, but you can't be too long. Okay, so this is triangle number 2 right here. Oops. Triangle number 1, triangle number 2. So 2 triangles if your opposite leg, okay, is bigger than the height, but not so big. It can't be opposite legs bigger than the height, but not so big to where it's bigger than the adjacent leg. Because if it's bigger than the adjacent leg, then you would only have 1 triangle. It's only long enough to where it goes sort of tucked inside, okay? So it has to be less than the adjacent leg. So let me erase this and put the adjacent leg in there. The adjacent leg, okay? So 2 triangles is when the opposite leg, which is this given angle, right, this leg right here, is bigger than the height. So you have to find the height, but at the same time, it has to be less than the adjacent leg. Okay, so let's go and try this example out. Example 2, solve for the triangle. So now that we have 2 sides and an angle, we have to do some sort of a test, okay? 2 sides and an angle. So you need to be worried about SS and A. Now, SSA is always the ambiguous one, but it's not going to be ambiguous unless it is in the right place. So if you are given one angle, always put this angle right here on the left corner. Not because you have to, but I promise you that's going to make your life so much easier, okay? Then opposite of leg A is 3 units because it's side A. Now, then you're given another leg, okay? An extra leg. This extra leg, I want you to put it right here on the top. Okay, let's call this leg B of 2 units, and that means angle B is right here. Again, not because you have to, but because it's easier to understand the ambiguous case when it's drawn that way, so you can see how it is compared. So we talked about opposite leg, okay, and adjacent leg of this angle. So check it out. Opposite leg is 3 units. Adjacent leg is 2 units. Can you see the opposite leg is bigger than the adjacent leg? So this opposite leg bigger than the adjacent leg. So that tells me there's only one triangle in this problem, which is really, really nice. I don't have to worry about solving for two triangles. So right now, this is one triangle because opposite leg is bigger than or equal to the adjacent leg, okay? So make sure you write this down so it's in your brain when you are taking the quiz or the final exam. So now let's find the missing part because it says solve for the triangle. What are you missing? Missing parts. The missing parts are, you're missing angle B, angle C, so let's put C right here, so this is leg C. You are missing leg C, and you are missing, that's it, okay, 3 parts. So since you're giving angle A, I'm going to use angle sine of A over little a equals, and you're giving leg B, so you have to use sine of B over leg B, and fill out some information. A is 40 degrees, leg A is 3 units, sine of B unknown over leg B is 2, and from here you want to cross multiply, so that's 2 sine of 40 degrees equals 3 sine of B. Okay, divide both sides by 3. So sine of B equals 2 sine of 40 degrees all over 3. Solve for B, so compose sine inverse to both sides. 2 sine of 40 degrees divided by 3. All right, now let's bust out our calculator. Are you ready to rumble? Okay, just kidding. Okay, let's go. Let's use a calculator. Punch it in. Let me know what you get. Let me go using mine. Okay. Clear out the old stuff. Okay, so I have to punch in. What I'm going to do first is I'm going to punch in the normal stuff first before I do sine inverse. So I'm going to do 2 times, open parentheses, sine of 40. Okay, close that up. So what is that answer? Then I need to divide it by 3. Divide the answer by 3. Hit enter. Then now I'm going to do sine inverse of that, sine inverse of that. So that gives me, let's round it to whole degrees because it's just easier to work with. Okay, so that's 25 degrees. So 25 degrees equals 25 degrees. So fill that in. For leg C, I'm not going to use the law of sines. I'm just going to use 180 minus leg A, angle A minus angle B, which is 25. That will give me angle C. Okay, so 180 minus 40, that's 140, minus 25, so that's 115. So angle C is 115 degrees. Then again, I'm just going to use the law of sine to find leg C. Okay, so sine of C over C equals, then I'm just going to use the exact one, not B, which is A, because you never ever want to use angle B. You rounded that. So sine of 115 over C equals sine of 40 over leg A, which is 3 units. Okay, cross multiply. So 3 times sine of 115 equals C times sine of 40 degrees. So divide both sides by sine of 40. So C equals 3 times sine of 115 all over sine of 40 degrees. Now, let's go and punch that in our calculator. All right, clear out the stuff. Okay, I need to punch in, let's see. What am I punching in again? 3 times sine of 115. Divide by sine of 40. So 3 times, open parentheses, 115, hit sine, close it up, equals. Then divided by, open parentheses, sine of 40, close that up, hit enter. So this one, leg C, comes out to be 4.23 units. 4.23 units. So C equals 4.23. So let's fill that in. 4.23 U. units. And that's how you solve that one out. But notice how we did check to see if it's one triangle, two triangles, or none. All right, let's do example B. Can you see that this is side, and angle again? And as stated earlier, make sure you put the given angle right here and label it letter A. Then that means opposite of this is 6 units, and that's letter A. And I want you to put the remaining leg right here. Let's make it B. I mean, this is angle B, so the remaining angle is C. I need to check to see how many triangles I'm going to end up with. If I'm going to check for triangles, okay, I need to find the height. So let's go and find the height. Okay. Now, find the height. Because I made it into a right triangle, I can just use normal, okay? Normal trig. So sine of 35 degrees equals opposite, which is h, over hypotenuse, which is 8 units, okay? So h equals 8 times sine of 35 degrees. Let's punch it in. Clear. 35 degrees sine, okay, times 8 is 4.59. 4.59. Okay, so this h is about 4.59. Okay, now look at your opposite leg. Opposite leg is 6 units, right? Is it questionable? Okay. Is it less than the adjacent leg? Opposite. Okay, so what I'm looking for is this. Is it two triangles, right? Because we want the opposite leg to be less than the adjacent leg. At the same time, both of those needs to be greater than the height. So let's verify real quickly. Is the opposite leg 6 less than the adjacent leg? Oops. Adjacent leg of 8. Yes, it is. At the same time, are these both greater than the height? The height is about 4.59 units. So check and check. So guess what? We have, voila, 2 triangles. We have 2 triangles, okay? So the first triangle is going to be just exactly the way that that green picture is drawn. So triangle number 1, okay? Missing parts are still angle B, angle C, and leg C. Let's call these C1s, A1, C1s, B1s, and little C1. And we're going to find it normally, okay? So let's do the law of sine. So sine of A over A equals sine of B over B. Well, I know sine of A, angle A is 35 degrees, leg A is 6 units, sine of B, which is, we don't know, we're trying to find that, over 8 cross multiply. So 8 times sine of 35 degrees equals 6 times sine of B. Divide both sides by 6. So 8 sine of 35 degrees divided by 6 equals sine of B. I need to take the inverse. So B equals sine inverse of this whole thing, which is 8 sine of 135 divided by 6. All right, let's punch it in. Okay, let me clear out my stuff. Clear. All right, let's punch it in. I'm going to do the normal first, okay? Because the normal one inside the parentheses is 8 sine of 135 divided by 6. Is it 135 or 35? Ooh, 35. Oh, my. 8 sine of 35. Sorry, guys. Okay. Divided by 6. So 8 times, open parentheses, sine of 35. Close it up. Hit enter. Divided by 6 first. Hit enter. Then whatever this value is, I'm going to do sine inverse. And then hit enter. So 8.31. So this angle is 8.31. Okay. Well, let me double check really quickly. 8 times sine of 35 divided by 6. Let me double check that really quick to see if that's what I have. Am I in degrees? Yeah, right. Okay. 35, hit sine, times 8. Okay. Divided by 6. Then sine inverse. Oh my gosh. Did I punch it wrong the first time around? That is so bizarre. What did I do wrong the first time? How come the first time gave me a different answer? Let me do that one more time. That's really confusing. Okay, I'm not like I said. This calculator is really confusing because I have to do the degrees first and then hit the sine button. Okay, so 35, which is sine. Okay, now whatever that answer is. Oh, I just divide by 6. That's so weird. Okay, maybe I did that wrong. So 8 times. Let's do this. 8 times parentheses 35 sine. Let's look. Close that up. Okay, hit enter. Divided by 6. Hit enter. Now sine inversed. Okay, so I've done it now twice. Then both of them came out to be 49.88. I'm going to round that up to 50 degrees. Okay, so angle B is 50 degrees. So go up and put that in. Now angle C, I'm just going to subtract it from 180. Okay, so angle C1, that's B1, equals 180 minus 50 degrees minus 35, that's given to us. So let's see, 180 minus 50, that's going to be 135. I mean, sorry, 130. 130 take away 35, so it's 95 degrees. So 95 degrees. Now let's go and find C1. Okay. Then C1, I'm definitely going to use sine of C over C equals sine of exact answer, which is angle A over A. Sine of 95 degrees over C equals sine of 35 over A with 6 units. So cross multiply, 6 times sine of 95 equals C times sine of 35 degrees. Divide both sides by sine of 35. So C equals 6 times sine of 95 degrees divided by sine of 35 degrees. All right, let me see if I can punch this in correctly. Okay, clear? 6 times, open parentheses, 95 sine. Close it up. Hit enter. Divided by, was that sine of, what was in the bottom? Sine of 35. Okay, divided by, open parentheses, 35 sine. Close that up. Okay. So that is giving me 10.42. So the angles, I'm rounding to whole number. And the legs, I'm just going to round it to 2 decimal places. 10.92. I'm sorry, 42. 10.42. All right. So fill that in. That's your C1. So I still have to go and find another one. 10.42 units. Okay. So what does a second one look like? Okay, all you're doing on the second one is, I'm going to use a different color now. I'm going to go over here and I'm going to put the second one right here. Okay, triangle number 2. So I'm still going to have the same missing parts, but let's just call it subscript 2. Okay, and what does it look like? You take this, you see this leg right here, which now I'm going to use, and then you swing it to the left side of the height, okay, and make a new one, and it's going to be like this. So what's happening is these two legs, okay, are the same leg. So technically, the only the second triangle is this one right here. Okay, this is the second triangle, not this. Okay, that is just, the triangle is technically the yellow highlighted one. So what I'm going to do is, as you can see, I'm going to draw it out again over here. Okay, so as you can see, the angles are still the same. You see it? So this is still A, and this is still 35 degrees. But your leg is now over here. So as you can see, this angle, which I'm going to use a different color, this right here, C2, it's an obtuse. Okay, sorry, that was leg B. That B2 is an obtuse, and C2 is now so much smaller than the original C. So this is your second triangle. Okay, so I'm going to try to find that. And all the measurements are still the same. This opposite leg is still 6 units. This is still 8 over here. You're just missing little C2 down here. Okay, so let's find them normally. Okay, well, let's talk about how would you find B2. Let me erase some things because it's getting too confusing here. Okay, even though, can you agree, we found B1 earlier. B1 was 50 degrees, okay? Because, let me get a different highlighter. Because this leg and these legs are exactly the same. So what does that mean from geometry? That means these two angles are exactly the same, okay? These two angles are both now going to be 50. Oops, let's wait for it to unfreeze. Okay, so those two angles are 50. So what's really leaving me is the C2. See this angle, this obtuse? Okay, so that's going to be bigger than earlier, okay? So because of 80 degrees, I can take away that 50 to give me B2. I keep saying C2, but it's really B2. So this B2 angle, class, B2 is really 180, take away B1. Take away B1. B1, you found it already. B1 is always that first normal one, okay? So 180, take away 50, which is now 130. So that's your 130 degrees, okay? Well, if you know B2 is 130, okay? Let me make this a little bit skinnier. Then you can easily find the top angle, okay? So the top angle is this tiny one right here, which is 180 minus angle A minus angle B2, okay? So let's, okay. So C2 is 180 minus B2 minus original angle A, which is 180 minus 30 minus original angle A was 35. So 180 minus 130, that's 50. 50 minus 35 is 15 degrees. So that's how small this one is, 15 degrees. Then C2, I can just now find it normally using the law of sine since it's not a right triangle. So sine of 15 degrees, which is C2 over small c2. And again, I'm back to using the exact sine of A, which is 35 degrees, over leg A, which is 6 degrees, cross multiply. So 6 times sine of 15 degrees equals C2 times sine of 35 degrees. Divide both sides by sine of 35 degrees. So 6 times sine of 15 degrees divided by sine of 35 degrees equals C2. Now let's go and punch in my calculator to see what it works. And I want to make sure I'm careful. All right, clear out what I have, okay? So I need to punch in 6. What was it again? Let's check. 6 times sine of 15 divided by sine of 35. Okay, 6 times, open parentheses, sine of 15, close that up, divided by, you know what? Can I just hit enter first? Let's clear that out. 6 times, open parentheses, sine of 15, because I'm not used to this calculator, so I want to hit enter first. And then divided by, open parentheses, sine of 35. Close that up. Okay. So it's super small, isn't it? It's 2.71. So little c is 2.71. So 2.71. And that is exactly how you find both triangles. Okay, and again, if this is really confusing, please do stop, listen to it again, and take down some notes.